Okay then guys, I'm going to be explaining rational exponents in this video, so let's get right into it. Before I get into these examples, I'll kind of briefly explain rational exponents, essentially just having a fraction as an exponent. So simple stuff, right? The first thing that I like to go over with my students before I get into this concept is just the idea of the square root. What is the square root? The square root is essentially something to the power of 1 over 2. So do this on your calculator, verify it for yourself. These are the same thing. What we actually don't see is we have to indicate what type of root a root is. So this is actually a square root. So this would be indicated by actually having a 2 over here. But if you just have a square root and there's no number next to it, just assume that it is a square root. If there's a root and there's no number next to it over here, then assume it's a square root. So perhaps I can go over a brief example explaining this. So this is pretty self-explanatory. We have basically a placeholder over here. We have a to the power of m, and we have a square root, a root that is of n. Essentially, that n value will be the denominator of the rational exponents, and the m will be the numerator of the rational exponents, right? So simple stuff. Maybe I'll just give you a quick example. So if you have something to the power of 3, so you have 16 to the power of 3, and let's say that we also have a cube root, okay? So this isn't a square root, this is a cube root, so it's slightly different. You can of course go ahead on your calculator and kind of like experiment with the values. So the m value 3 would be on top, and the n value 3 would be at the bottom. So these are actually the same thing, but either way, I just want to show you that these can also cancel out to just give you 1. You just have 16, right? So yeah. Now let's get into these examples over here. So this first one over here, down over here, I'll kind of try to reference what I'm doing to this, sort of this conversion between the rational form, the radical form, and having the exponential form, right? Okay, so for this one, nice and simple. So first, what type of root is this? This is a cube root. You can identify this by looking at sort of the n value, which comes from here, right? So yeah, you kind of do this comparison in your head, and also look at the m value over here. Right, so I'm going to get rid of all these arrows because they're blocking everything, but yeah. Make sure to constantly do that connection. Constantly do that connection. That's how you get better at this stuff, honestly. So, I'm just going to do the square of this, so I'll just do it on my calculator. So bracket negative 216 squared, or close bracket square. So basically just like put in the brackets first and then the square. So you get like 4, 6, 6, 5, 6 cube root, and take the cube root of that. Usually on your calculator you could just find the cube root. Perhaps it's on the same button as the square root, but you just have to press shift or something like that. And there's also should be another feature for you to use any root that you like. So then you put like a number, and then you put the sort of like that type of like root. So you probably see it on your calculator. It'll be hard to explain without me actually showing you the calculator. So yeah, take the cube root of that, you get 36. Cool, that's your final answer. Move on to the next one. Alright, so I know it's tempting for this one just to look at this and be like, okay, same base, let me just subtract the exponents. And yes, you can do that, 100%. But I'm just showing you a slightly different way over here. So the bottom, so you see over here, this is to the power of 1 over 3. So our m value is just 1, right? But our n value is 3. And there's no reason to really put a 1 there, you know? So we can just get rid of that. Okay, and as for the top, similar thing, we got an n value of 3, so we put that over there, 5, but this time we actually do have a relevant n value. oh, sorry, I was actually referring to them in the incorrect way. We have a relevant m value. It might be hard for me, it might be hard for you guys to even hear me say the difference between m and n, digitally especially. So yeah. But anyway, this 2, the numerator goes in the square root. The denominator goes outside the square root. So you can remember it in that way. Denominator outside the square root, or outside the root actually, and the numerator inside the root. Okay. So yeah. A couple of ways you can go about this, but the way that I would prefer to go about this is writing it out like this, since we have this squared, and like this, and then you can cancel it out, and all you are left with is this. Nice. Okay, that's our final answer. Okay, let's get into this last one over here. I feel like I'm starting to run out of space, but anyway, let's get into this one. So there's a couple of ways that you can go about it, but I believe the most effective way, or the best way to go about this, is first just get rid of this negative exponent. We hate negative exponents, we want to get rid of them. And generally, one tip for you is like, in your final answer of any question that you do in math, don't have a negative exponent. Always convert that into a positive exponent. How do we do that? We basically take the reciprocal. So you can go about it like this. So just leave a 1 up there. 12, 27 to the power 2. 3 divided by 2. So I wrote it out like this, but basically you can just skip that step and you can just go straight to this. So yeah. Alright. Okay. So how do we go about it from here? Now we can actually apply this whole exponent to the numerator and the denominator. Okay. So let's go about that. So I'll kind of write it out. Just like that first step. So let me write that. Put this down here. Yeah, okay. Okay, now I'm going to do the whole conversion into a rational, or a radical form. Sorry, I keep on mixing up the two. But yeah, turn this from exponential form into like a radical form, basically like the root form, right? So let me do that. Once again, I want you to reference what we have up here. So just keep on looking at this, maybe pause it right here, and just like see the difference between the two of what I'm doing. Okay. Once again, the numerator is what will be inside the brackets, and what is the denominator would be outside the brackets. So this would be 2. Both of these would be 2, and that just means that it's just a square root. So I usually don't include the number outside of there if I do a square root. So same thing over here. Okay. So you can leave it like that. And now there's a couple ways that you can do about this. I'm just going to do this in the way that makes the most sense to me. And I'll kind of write out the steps so it's more clear to you what I'm actually thinking. So I would actually write this down like this. Okay. Okay. All right, so I'm going to skip a step here. So just be very careful of like seeing what I'm doing from one step to the other. So what I'm actually going to do is just focus on one of these and split it into 2 terms. So you may remember this from previous lessons of how to simplify radicals, simplifying roots, right? So I could split this into 2 numbers. So let me think. I could do like 4 and 3. Why am I picking those numbers instead of like 6 and 2? Because 4 is square rootable, quote unquote. So 4 times square root of 3, okay? So this, basically what we have over here is equal to this, okay? So just keep that in mind. And this would be to the power of 3, because basically I just wrote this out for 1, but we have 2 other ones here, right? We have 3 in total. So I'm just putting this to the power of 3, because we're all multiplying these. And we're going to do the same thing for the top. So I think I could do 9, square root of 9, and square root of 3, okay? And once again, to the power of 3, because we have 3 terms over here. Okay, from here it's pretty simple. So, just simplify this these roots. So 2 and 3. And remember that this exponent applies to both of these terms, okay? So this to the power 3, this to the power 3. Oh, whoops. I put that as a square, not a to the power 3. Yeah, there you go. Oh, and also we can just put this as 3 as well. Just simplify. So square root of 943. So, okay, from here it's pretty easy. We just cancel these two out. Perfect. So now we can just apply these squares or apply these exponents. So 2 to the power of 3 should be 8. 2 times 2 times 2. And 3 to the power of 3 should be 27. So 3 times 3 times 3. So 9 times 3. Yeah, that works. Okay, cool. That is our final answer. And that is rational exponents. Basically just having what to do when you have a fraction as an exponent. So yeah, so you kind of get this idea. The main thing to keep in mind is just how to convert between the two, okay? And rest of that from there is just practice. And also just keep in mind when you have a square root or there's no square root, or sorry, when you have a root and there's no n value here, just remember that it's actually just there's a 2 over there, so the n value is actually 2. Okay, so just keep that in mind. Just a quick little tip. Okay, and I hope that you enjoyed this lesson. You don't have to do math the way that I do it over here, but if you need some guidance, perhaps this has helped.